Universitas Tanjung Pura.
Pernahkah kamu berpikir bahwa data dapat membantu kamu untuk membuka pola, atau memprediksi tren, atau bahkan membantu kamu untuk membuat keputusan yang penting?
Di Prodi Statistika FMIPA Universitas Tanjung Pura, kamu akan belajar bagaimana cara mengolah, menganalisis, dan menginterpretasikan data di berbagai bidang.
Kamu bisa memilih bidang minat sesuai dengan passionmu. Di program studi statistika terdapat 3 pilihan bidang minat yang dapat kamu pilih. Ada bisnis dan keuangan, sosial dan industri, dan lingkungan dan kebencanaan.
Kabar baiknya, di program studi Statistika UNTAN, kamu bisa lulus dengan rata-rata 3,5 tahun.
Ada 3 jalur masuk yang dapat kamu pilih untuk bergabung di Program Studi Statistika FMIPA UNTAN. Yang pertama jalur SNBP, yang kedua jalur SNBT, dan yang ketiga jalur mandiri.
Jadilah bagian dari generasi yang membangun masa depan berbasis data. Daftarkan dirimu di Prodi Statistik Fakultas Matematika dan Ilmu Pengetahuan Alam Universitas Tanjung Pura.
Pernahkah kamu berpikir bahwa data dapat membantu kamu untuk membuka pola, atau memprediksi tren, atau bahkan membantu kamu untuk membuat keputusan yang penting?
Di Prodi Statistika FMIPA Universitas Tanjung Pura, kamu akan belajar bagaimana cara mengolah, menganalisis, dan menginterpretasikan data di berbagai bidang.
Kamu bisa memilih bidang minat sesuai dengan passionmu. Di program studi statistika terdapat 3 pilihan bidang minat yang dapat kamu pilih. Ada bisnis dan keuangan, sosial dan industri, dan lingkungan dan kebencanaan.
Kabar baiknya, di program studi Statistika UNTAN, kamu bisa lulus dengan rata-rata 3,5 tahun.
Saya belum kuning.
Ada 3 jalur masuk yang dapat kamu pilih untuk bergabung di Program Studi Statistika FMIPA UNTAN. Yang pertama jalur SNBP, yang kedua jalur SNBT, dan yang ketiga jalur mandiri.
Jadilah bagian dari generasi yang membangun masa depan berbasis data. Daftarkan dirimu di Prodi Statistik Fakultas Matematika dan Ilmu Pengetahuan Alam Universitas Tanjung Pura.
Pernahkah kamu berpikir bahwa data dapat membantu kamu untuk membuka pola, atau memprediksi tren, atau bahkan membantu kamu untuk membuat keputusan yang penting?
Di Prodi Statistika FMIPA Universitas Tanjung Pura, kamu akan belajar bagaimana cara mengolah, menganalisis, dan menginterpretasikan data di berbagai bidang.
Kamu bisa memilih bidang minat sesuai dengan passionmu. Di program studi statistika terdapat 3 pilihan bidang minat yang dapat kamu pilih. Ada bisnis dan keuangan, sosial dan industri, dan lingkungan dan kebencanaan.
Kabar baiknya, di program studi Statistika UNTAN, kamu bisa lulus dengan rata-rata 3,5 tahun.
Ada 3 jalur masuk yang dapat kamu pilih untuk bergabung di Program Studi Statistika FMIPA UNTAN. Yang pertama jalur SNBP, yang kedua jalur SNBT, dan yang ketiga jalur mandiri.
Jadilah bagian dari generasi yang membangun masa depan berbasis data. Daftarkan dirimu di Prodi Statistik Fakultas Matematika dan Ilmu Pengetahuan Alam Universitas Tanjung Pura.
Pernahkah kamu berpikir bahwa data dapat membantu kamu untuk membuka pola, atau memprediksi tren, atau bahkan membantu kamu untuk membuat keputusan yang penting?
Di Prodi Statistika FMIPA Universitas Tanjung Pura, kamu akan belajar bagaimana cara mengolah, menganalisis, dan menginterpretasikan data di berbagai bidang.
Kamu bisa memilih bidang minat sesuai dengan passionmu. Di program studi statistika terdapat 3 pilihan bidang minat yang dapat kamu pilih. Ada bisnis dan keuangan, sosial dan industri, dan lingkungan dan kebencanaan.
Kabar baik. baiknya, di program studi Statistika UNTAN, kamu bisa lulus dengan rata-rata 3,5 tahun.
Ada 3 jalur masuk yang dapat kamu pilih untuk bergabung di Program Studi Statistika UNTAN. Yang pertama jalur SNBP, yang kedua jalur SNBT, dan yang ketiga jalur mandiri.
Jadilah bagian dari generasi yang membangun masa depan berbasis data. Daftarkan dirimu di Prodi Statistik Fakultas Matematika dan Ilmu Pengetahuan Alam, Universitas Tanjung Pura.
Pernahkah kamu berpikir bahwa data dapat membantu kamu untuk membuat pola, atau memprediksi tren, atau bahkan membantu kamu untuk membuat keputusan yang penting?
Di Prodi Statistika FMIPA Universitas Tanjung Pura, kamu akan belajar bagaimana cara mengolah, menganalisis, dan menginterpretasikan data di berbagai bidang.
Kamu bisa memilih bidang minat sesuai dengan passionmu. Di program studi statistika terdapat 3 pilihan bidang minat yang dapat kamu pilih. Ada bisnis dan keuangan, sosial dan industri, dan lingkungan dan kebencanaan.
Kabar baiknya, di program studi Statistika UNTAN, kamu bisa lulus dengan rata-rata 3,5 tahun.
Ada 3 jalur masuk yang dapat kamu pilih untuk bergabung di Program Studi Statistika UNTAN. Yang pertama jalur SNBP, yang kedua jalur SNBT, dan yang ketiga jalur mandiri.
Jadilah bagian dari generasi yang membangun masa depan berbasis data. Daftarkan dirimu di Prodi Statistik Fakultas Matematika dan Ilmu Pengetahuan Alam, Universitas Tanjung Pura.
Pernahkah kamu berpikir bahwa data dapat membantu kamu untuk membuat pola, atau memprediksi tren, atau bahkan membantu kamu untuk membuat keputusan yang penting?
Di Prodi Statistika FMIPA Universitas Tanjung Pura, kamu akan belajar bagaimana cara mengolah, menganalisis, dan menginterpretasikan data di berbagai bidang.
Kamu bisa memilih bidang minat sesuai dengan passionmu. Di program studi statistika terdapat 3 pilihan bidang minat yang dapat kamu pilih. Ada bisnis dan keuangan, sosial dan industri, dan lingkungan dan kebencanaan.
Kabar baiknya, di program studi Statistika UNTAN, kamu bisa lulus dengan rata-rata 3,5 tahun.
Ada 3 jalur masuk yang dapat kamu pilih untuk bergabung di Program Studi Statistika UNTAN. Yang pertama jalur SNBP, yang kedua jalur SNBT, dan yang ketiga jalur mandiri.
Jadilah bagian dari generasi yang membangun masa depan berbasis data. Daftarkan dirimu di Prodi Statistik Fakultas Matematika dan Ilmu Pengetahuan Alam, Universitas Tanjung Pura.
Pernahkah kamu berpikir bahwa data dapat membantu kamu untuk membuat pola, atau memprediksi tren, atau bahkan membantu kamu untuk membuat keputusan yang penting?
Di Prodi Statistika FMIPA Universitas Tanjung Pura, kamu akan belajar bagaimana cara mengolah, menganalisis, dan menginterpretasikan data di berbagai bidang.
Kamu bisa memilih bidang minat sesuai dengan passionmu. Di program studi statistika terdapat 3 pilihan bidang minat yang dapat kamu pilih. Ada bisnis dan keuangan, sosial dan industri, dan lingkungan dan kebencanaan.
Kabar baiknya, di program studi Statistika UNTAN, kamu bisa lulus dengan rata-rata 3,5 tahun.
Ada 3 jalur masuk yang dapat kamu pilih untuk bergabung di Program Studi Statistika UNTAN. Yang pertama jalur SNBP, yang kedua jalur SNBT, dan yang ketiga jalur mandiri.
Jadilah bagian dari generasi yang membangun masa depan berbasis data. Daftarkan dirimu di Prodi Statistik Fakultas Matematika dan Ilmu Pengetahuan Alam, Universitas Tanjung Pura.
Pernahkah kamu berpikir bahwa data dapat membantu kamu untuk membuat pola, atau memprediksi tren, atau bahkan membantu kamu untuk membuat keputusan yang penting?
Di Prodi Statistika FMIPA Universitas Tanjung Pura, kamu akan belajar bagaimana cara mengolah, menganalisis, dan menginterpretasikan data di berbagai bidang.
Kamu bisa memilih bidang minat sesuai dengan passionmu. Di program studi statistika terdapat 3 pilihan bidang minat yang dapat kamu pilih. Ada bisnis dan keuangan, sosial dan industri, dan lingkungan dan kebencanaan.
Kabar baiknya, di program studi Statistika UNTAN, kamu bisa lulus dengan rata-rata 3,5 tahun.
Ada 3 jalur masuk yang dapat kamu pilih untuk bergabung di Program Studi Statistika UNTAN. Yang pertama jalur SNBP, yang kedua jalur SNBT, dan yang ketiga jalur mandiri.
Jadilah bagian dari generasi yang membangun masa depan berbasis data. Daftarkan dirimu di Prodi Statistik Fakultas Matematika dan Ilmu Pengetahuan Alam, Universitas Tanjung Pura.
Cara nengok ini.
Pernahkah kamu berpikir bahwa data dapat membantu kamu untuk memperpola, atau memprediksi tren, atau bahkan membantu kamu untuk membuat keputusan yang penting?
Di Prodi Statistika FMIPA Universitas Tanjung Pura, kamu akan belajar bagaimana cara mengolah, menganalisis, dan menginterpretasikan data di berbagai bidang.
Kamu bisa memilih bidang minat sesuai dengan passionmu. Di program studi statistika terdapat 3 pilihan bidang minat yang dapat kamu pilih. Ada bisnis dan keuangan, sosial dan industri, dan lingkungan dan kebencanaan.
Kabar baiknya, di program studi Statistika UNTAN, kamu bisa lulus dengan rata-rata 3,5 tahun.
Ada 3 jalur masuk yang dapat kamu pilih untuk bergabung di Program Studi Statistika UNTAN. Yang pertama jalur SNBP, yang kedua jalur SNBT, dan yang ketiga jalur mandiri.
Jadilah bagian dari generasi yang membangun masa depan berbasis data. Daftarkan dirimu di Prodi Statistik Fakultas Matematika dan Ilmu Pengetahuan Alam, Universitas Tanjung Pura.
Pernahkah kamu berpikir bahwa data dapat membantu kamu untuk memperpola, atau memprediksi tren, atau bahkan membantu kamu untuk membuat keputusan yang penting?
Di Prodi Statistika FMIPA Universitas Tanjung Pura, kamu akan belajar bagaimana cara mengolah, menganalisis, dan menginterpretasikan data di berbagai bidang.
Kamu bisa memilih bidang minat sesuai dengan passionmu. Di program studi statistika terdapat 3 pilihan bidang minat yang dapat kamu pilih. Ada bisnis dan keuangan, sosial dan industri, dan lingkungan dan kebencanaan.
Kabar baiknya, di program studi Statistika UNTAN, kamu bisa lulus dengan rata-rata 3,5 tahun.
Ada 3 jalur masuk yang dapat kamu pilih untuk bergabung di Program Studi Statistika UNTAN. Yang pertama jalur SNBP, yang kedua jalur SNBT, dan yang ketiga jalur mandiri.
Jadilah bagian dari generasi yang membangun masa depan berbasis data. Daftarkan dirimu di Prodi Statistik Fakultas Matematika dan Ilmu Pengetahuan Alam, Universitas Tanjung Pura.
Pernahkah kamu berpikir bahwa data dapat membantu kamu untuk memperpola, atau memprediksi tren, atau bahkan membantu kamu untuk membuat keputusan yang penting?
Di Prodi Statistika FMIPA Universitas Tanjung Pura, kamu akan belajar bagaimana cara mengolah, menganalisis, dan menginterpretasikan data di berbagai bidang.
Kamu bisa memilih bidang minat sesuai dengan passionmu. Di program studi statistika terdapat 3 pilihan bidang minat yang dapat kamu pilih. Ada bisnis dan keuangan, sosial dan industri, dan lingkungan dan kebencanaan.
Kabar baiknya, di program studi Statistika UNTAN, kamu bisa lulus dengan rata-rata 3,5 tahun.
Ada 3 jalur masuk yang dapat kamu pilih untuk bergabung di Program Studi Statistika UNTAN. Yang pertama jalur SNBP, yang kedua jalur SNBT, dan yang ketiga jalur mandiri.
Jadilah bagian dari generasi yang membangun masa depan berbasis data. Daftarkan dirimu di Prodi Statistik Fakultas Matematika dan Ilmu Pengetahuan Alam, Universitas Tanjung Pura.
Pernahkah kamu berpikir bahwa data dapat membantu kamu untuk membuka pola, atau memprediksi tren, atau bahkan membantu kamu untuk membuat keputusan yang penting?
Di Prodi Statistika FMIPA Universitas Tanjung Pura, kamu akan belajar bagaimana cara mengolah, menganalisis, dan menginterpretasikan data di berbagai bidang.
Kamu bisa memilih bidang minat sesuai dengan passionmu. Di program studi statistika terdapat 3 pilihan bidang minat yang dapat kamu pilih. Ada bisnis dan keuangan, sosial dan industri, dan lingkungan dan kebencanaan.
Kabar baiknya, di program studi Statistika UNTAN, kamu bisa lulus dengan rata-rata 3,5 tahun.
Ada 3 jalur masuk yang dapat kamu pilih untuk bergabung di Program Studi Statistika FMIPA UNTAN. Yang pertama jalur SNBP, yang kedua jalur SNBT, dan yang ketiga jalur mandiri.
Jadilah bagian dari generasi yang membangun masa depan berbasis data. Daftarkan dirimu di Prodi Statistik Fakultas Matematika dan Ilmu Pengetahuan Alam, Universitas Tanjung Pura.
Tidak ada suaranya.
Bang Melawi 19% ya.
And precious chance for me to be your master at the ceremony this afternoon, Monday, 7th of July 2025, in our big event, a Studium Generale with the theme Stochastic Approximation Algorithm in the context of functional data application in Big Data and EEG. Excellencies, ladies and gentlemen, before proceeding to the next agenda, allow me to present the sequence of events for today's agenda. First, opening. Second, singing the national anthem of Indonesia. Third, report from the chairperson of the committee. Fourth, prayer. Fifth, documentation session. Sixth, material presentation and discussion session. And the last, closing. So first, to begin our event today, let us recite the basmalah together. Bismillahirrahmanirrahim. Next, singing the national anthem of Indonesia, we kindly ask everyone to stand up. Thank you, everyone, and please be seated. Next, we would like to invite the chairperson of the committee to deliver the report. To Mrs. Nur Fitri Imro'ah, SSE, MSE, the floor is yours.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Good afternoon, ladies and gentlemen, the Honorable Heads and Secretaries of Mathematics Department, our distinguished speaker, Professor Dr. Yousri Sloui from Universite de Poitiers, our moderator, Ms. Dr. Yousri from Universitas Tanjung Pura, esteemed lecturers, students, and all participants joining us on site and online. First and foremost, let us express our gratitude to Almighty God for the blessings and help that allow us to gather today for this event with the topic Stochastic Approximation Algorithm in the context of functional data application in Big Data and EEG. Ladies and gentlemen, on behalf of the organizing committee, I would like to extend a warm welcome and deep appreciation to Professor Yousri for accepting our invitation and for generously sharing his expertise with us. It is an honor to have him here, and we believe his insight will greatly enrich our academic perspective, especially in the field of statistics, mathematics, data science, and functional data analysis. This event is attended by more than 100 participants from various institutions, both within and outside Universitas Tanjung Pura. The purpose of this event is to broaden our understanding of stochastic approximation method and their application in Big Data and EEG. We would also like to express our sincere thanks to everyone who contributed to the success of this event, the faculty members, organizing teams, and all enthusiastic participants who have registered and taken part in this academic forum. We hope that today's session will bring valuable knowledge and open opportunities for future academic and research collaboration. Thank you very much for your attention. Please accept our apologies for any shortcomings. Wassalamualaikum warahmatullahi wabarakatuh.
Thank you, Mrs. Nur Fitri Imro'ah, SSE, MSE, for the report. The next agenda is prayer. We invite Mr. Adika Dapo to lead the prayer.
Assalamualaikum warahmatullahi wabarakatuh. Marilah sejenak kita bersama-sama berdoa bermunajat kepada Tuhan kita agar kegiatan kita pada hari ini dapat diberkahi dan dapat berjalan dengan lancar. Bagi yang beragama Islam, izinkan saya untuk memimpin doa ini. A'udzubillahiminasyaitonirrajim. Bismillahirrahmanirrahim. Alhamdulillahirabbil alamin. Wassalatu wassalamu ala asyrofil anbiya'i wal mursalin wa ala alihi wa sahbihi ajma'in, amma ba'du. Ya Allah ya Rahman, pada siang hari ini kami hendak menyelenggarakan kuliah umum yang berjudul Stochastic Approximation Algorithm in the context of functional data application in Big Data and EEG. Dengan memohon ridho dan izin-Mu, berkahilah semua langkah dan perbuatan kami, dan jadikan semua itu nilai ibadah dan ilmu yang bermanfaat bagi kami. Allahumma anta rabbi, la ilaha illa anta khalaqtani, wa ana abduka, wa ana a'la ahdika, wa wa'dika mastata'tu, a'udzubika min syarri ma sana'tu, abu'u laka bini'matika alayya wa abu'u bizambi faghfirli fa innahu la yaghfirudz dzunuba illa anta. Ya Allah ya Ghafur, ampunilah dosa kami, dosa kedua orang tua kami, dosa para pemimpin kami, dosa para pendahulu kami, dan dosa orang-orang yang telah berjasa bagi pendidikan kami. Tempatkanlah senantiasa kami dan mereka semua ini dalam naungan perlindungan dan rahmat-Mu. Ya Allah, kami memohon perkuatkanlah persatuan dan kesatuan di antara kami. Janganlah Engkau biarkan ada perpecahan di antara kami, agar dapat lebih bermanfaat bagi agama, nusa, dan bangsa. Allahumma inni as'aluka bi anni asyhadu annaka antallahu la ilaha illa antal ahadus samad alladzi lam yalid wa lam yulad wa lam yakul lahu kufuwan ahad. Ya Allah yang mujib, perkenankanlah doa dan permohonan hamba-Mu yang lemah ini. Rabbil fa'na bima alamtana, Rabbi alimna alladzi yanfa'una, Rabbi faqina wa faqi ahlana, wa qarabatil lana fi dinina, tawassalna bi ta'allumin, antarzuqna al-wasi'ah, wa antarzuqna al-amanah. Subhana rabbikal rabbil izzati amma yasifun, wassalamun alal mursalin, walhamdulillahi rabbil alamin. Assalamualaikum warahmatullahi wabarakatuh.
Thank you, Mr. Adika, for leading the prayer. The next agenda is the photo session. First, we kindly ask all lecturers of mathematics department to come forward. I will guide the documentation in 3, 2, 1. Please, once again, in 3, 2, 1. Okay, thank you. You all can return to your seat. Oh. Okay, the documentation in 3, 2, 1. Thank you. You all can return to your seat, but please keep standing. Please keep standing. We also kindly invite Professor Dr. Yousri Sloui and Mrs. Dr. Evi Sulistian to join the mathematics department lecturers for the photo sessions. And I kindly ask all participants to stand up too, because we want to take the documentation together. For online participants, please kindly turn on your camera so you can be part of this moment as well. I will guide the documentation in 3, 2, 1. Once again. 3, 2, 1. Okay. Thank you, everyone. Please be seated. And finally, we have reached the end of the opening session for today's Studium Generale with the theme Stochastic Approximation Algorithm in the context of functional data application in Big Data and EEG. Well, ladies and gentlemen, we will now come to the main event, the presentation session from our extraordinary speaker. The presentation session will be moderated by our esteemed moderator, and allow me to introduce our wonderful moderator for today. She is Mrs. Dr. Yousri Sloui, MSc, a lecturer at the Department of Mathematics, Universitas Tanjung Pura, with extensive experience in teaching, research, and academic leadership. Mrs. Effie earned her degrees in Mathematics and Financial Statistics from Universitas Tanjung Pura and Universitas Gadjah Mada. She has held several strategic positions in academia and is currently the coordinator of the Statistics Study Program. Her research focuses on financial risk management and quantitative finance. She is also active in professional associations and serves as a peer reviewer for international journals. For more detailed information, you may refer to the screen. Mrs. Effie has actively published scientific articles in reputable international journals. Some of her publications include Geometric Brownian Motion with Jump Diffusion and Value at Risk Analysis of PT Bank Negara Indonesia Stocks, Index Scopus Q4 in 2025, Credible Delta Normal Value at Risk for a risk evaluation of European call option, Index Scopus Q3 in 2023, Measuring Risk Utilizing Credible Monte Carlo Value at Risk and Credible Monte Carlo Expected Sale Loss, Index Scopus Q3 in 2022. So that's all the brief introduction from our moderator, and without any further ado, please welcome our incredible moderator, Mrs. Dr. Yousri Sloui, MSc. To Mrs. Effie, you might take the floor.
Okay, thank you, Gandes. Good afternoon, ladies and gentlemen. Bonjour, mesdames et messieurs. Okay. On behalf of the Department of Statistics, Program Studi Statistika, I warmly welcome you to today's Studium Generale, online and offline, which entitles Stochastic Approximation Algorithm in the context of functional data, application in big data, and EEG. My name is Dr. Yousri Sloui, and I have the honor of serving you as your moderator for this session. It is a great pleasure to host Professor Yousri Sloui from Universite de Poitiers, France, a highly respected scholar in the field of stochastic approximation, functional of data analysis, and its applications in complex datasets such as the double EEG signals and also big data environments. Okay. His research has significantly contributed to advancing both theoretical frameworks and applied methodologies in statistics, and we are truly fortunate to have him here with us today. Let us take this opportunity for the audience not only to listen and learn, but to also engage in meaningful dialogue as we explore the cutting edge of the statistical science. Okay, for the curriculum vitae, Professor Yousri Sloui has some scientific responsibilities. He is a guest editor for the special issue Stochastic Models and Statistical Inference, and also the associate editor for the journal from Years in Applied Mathematics and Statistics in 2023. And he also is an editor for the journal Statistics Optimization and Information Computing since July 2023. Okay. He selected articles such as non-parametric estimation for random effects model, polynomials, factor analysis, and their application to the assessment of chronic and statistic disease in 2023. Okay, Professor Yousri Sloui also has published many articles, and we cannot mention published articles, but
We know that Professor Yousri Sloui is a distinguished speaker for today. Our distinguished speaker, Professor Yousri, and his presentation. Please, Professor, his credentials.
Thank you very much. Thank you for the invitation and for the presentation. We move. We start by title, as you can see, is about stochastic approximation algorithm. So we see what's read by functional data, and then we will see some application in what we call by big data. And for application of EEG, for electromagnetic therapy, this means psychological data. So this is the structure of our talk. We will start by an introduction of stochastic approximation algorithm. Then we will talk about function data in physics. And then we talk about condition, then supervised classification with an application to psychological data. And the fifth part, we compare our proposal to a parametric estimator. So we see how we construct our estimators, and we see in the literature if there are another possibility to use another estimator in our case. And we talked about some perspective and ways by giving some reference, some bibliography. So we are now in the context of non-parametric statistics. That's meaning we observe our data and we don't know, we have no information about the density or distribution of our observation. That means that we don't consider that it flows Gaussian, some Gaussian or exponential or other type of so stochastic approximation algorithm. So I give this formula, but in few words, if we construct our estimator based on n or a number, fixed number of data, okay? And we have one more observation. The stochastic approximation algorithm permits us to combine this new information to get our estimator by the fixed between n observation and the time observation. Okay? Fixing all the observation in a data set. And that will be very useful because if we have this for one observation, that means if we have two separate data sets, we can't combine them. Okay. So this is the general form of the classic algorithm. Defined as we can see here. Here data is the quantity which just symmetrical symmetry. That is the step size of our algorithm. The function of how the is updated as a function of the new observation. Okay. And mu is a small perturbation of the algorithm. So the behavior of this algorithm was studied by literature. I list some here. And I give you some example of application that we can find in the literature. The next algorithm is close to this one, which is much more easily. That's really possible to make to come to this one, which is easier with phi as a middle function. And this one includes two well-known algorithms, which are really narrow and capable units. And these two algorithms consider this assumption on WN. That's the expectation of the function of the past is equal to 0. And which this assumption very useful to construct our recursive estimator. So this we go through some authors who was interested to show that data converge to data star almost solely. So the motivations are really making the motivations of using stochastic approximation algorithm is to construct a recursive estimator. That means it can be updated from their immediate past and the new observations. And the update can be computed immediately and then you require extensive storage of data. And then it is useful for big data. Okay? Now we want to apply this approximation stochastic algorithm in the time of functional data. So I will introduce to what we mean by functional data. So functional data we mean that we observe, for example, patients that have many measurements. But this measurement should basically just 10, 20, 30, which show that we have different observations. In practice, we consider like 200 or something. So the first possibility, if we have the scales, we talk multivariate statistics. But as you know, there are many problems by considering multivariate statistics. For example, the first problem is one, when the number of variables is the number of observations. So in this case, we can consider that we go with functional analysis. And what is functional analysis? A dynamic variable which take a variable infinite space. It says so infinite space. That means our observations in N is really huge. So it is technically impossible to measure X data for each data, but it's possible to find a small discontinuation to X data for I give you some example here. For example, spectral charge. To estimate percentage of brightness of those elements. So this information we can have it, but it's very expensive. To consider our relation model to have this information. So this is first example functional data. In many times there is some choice for multi-C surface temperature from June 1950 to the you can see the trajectory. So maybe give just some example, you can find. So this is actually conception time series. Spectrometry, let's just give this example. We have 250 units and observe all of this spectrometry code. And the last example is the electroencephalography. We can see later about this example. We have 128 electrodes in the scale, and we have this illustration when we see a picture. There's a man sitting, and when we see a picture, so I'm going to give it exactly in just the period between when we see the picture and the first movement in the table. Okay? This is this quick time of many processes that we can made. And we see how we can find exactly the vision of each one associated with each part of the world. So we see for sometimes so the question that you have, the first thing we classify into category. That's what we interested by the classification problem. Second, the reports on the form other characteristic. Interested by the information. And associate, for the example, that we see the first one to the electroencephalography and the second one of spectrometry code. Okay. Prediction. We will start by prediction. So the prediction we consider in our problem as the response of the model, which is called Y, and X behind the boundaries. It is possible to consider the boundary also, okay? But here in this, we consider just the dependence. With in real values, which could be also occurred, but in our situation, we consider just in M. And X like branch in some functional space, it could be of M. If we consider just T in R, that we just about if we consider T by L second, that we consider image. But it's possible, and possible extension. So our model is arising just like this. Epsilon is the expectation is equal to 0, and the time is infinite. Classical assumption on the level of the model. So I need to broken, I use some. Give example, special families is spectrometry probe with the kind of the and our goal is to construct a recursive estimate of the unknown operator. So you see through that we start by considering estimation, which implies the square error, the function of the operator which means the square error as we define as the square. So we should control the decision duration is this is the expectation of the response of the function. So this is in the case of non-parametric statistic, which are interested, but also in the parametric estimation, we have this quantity. So, statistical functional data, by 2002, which can be viewed as an adaptation of the various estimator numbers in 1964 out there. This estimator can be written as follows. H choose seconds, seconds go to zero, and L is K is the kernel. Integral of K to 1. Consider usually a second order kernel is integral z squared times z is fixed. Others equal to 0 is my integral z times z equal to 0. So I'm just to construct a recursive structure. Check in the literature. One does the previous paper proposed by Oleh 2014, which is an adaptation which we can not show in the fixed dimensional region statistics. Visualizing as follows, where f is the cumulative solution function. So in 2020, I proposed this estimator Statistika UNTAN, which is written as follows, where the annual quantity is P, which is the values of 1 minus the step size and the power of the and this is also construct by using stochastic approximation algorithm. I will show you later how we construct this estimator. But just to show the difference, you can see it's much different from the others. But it comes from the approximation. HK, much fixed which this estimator is more general than this one. Considering a chosen step size, we have this time this estimator. But this one is more general than so exactly as a ratio of two recursive estimators. And then which can be recursive and which can be recursive also. But it's not a recursive estimator, but we have only recursive. That's meaning one observation we can avoid estimation. See here, so using this new observation, it's n and f. Okay. So I knew discuss choice, the optimal choice of kernel, talk about the optimal choice of HM, which is the best parameter. Let's take care of choosing. Step start. Choice of I will not discuss the choice of in the statistics I will talk about also the choice of another proposition to have a recursive estimator. That's given. We consider that we can 2 times scale stochastic approximation algorithm. It's meaning as we can see it's an reflection of R in this one. This quantity will be f, which is It's also inclusively. As we have a very important information because our knowledge of angles is so true subsides from very faster to zero than another situation before as I show you about situation we have levels of powers. So the consider is some ways observations situation and consider so this entity as a result is a logical function. Assume expectation of one observation expectation is to observation. This was in virtual knowledge statistics, but now to succeed this is essential. In 2019, just same things as for example in the first row. Now it involves purest demonstration most this scenario. So to demonstrate algorithm, approximation algorithm in Juli, was calls Juli and Judul. Juli is quantity, Judul so to consider the scenario of this quantity, and in this quantity that we call GG. So we consider approximation approximate the reflection of reflection of H to say y G is magnified. G to G and equal G was one the step size is the observation. The observation was that's two was two no is better the observation of H at one she runs out just once one increase and we find an approximation an estimation of G but the expectation should be equal to zero we see the expectation of one function of the past show this expectation function. So these approaches, as I say, observation by observation, signals, which come from different sides. Side estimation, it's true. It's symmetry. Now this measure so for the same so this expression shows us so just two signals signals symmetry and research. This is their interpretation. What about So, see, show. It's very also, that's, I mean, that's the, I will just show you the area of the, then you check, mathematical. So, we consider, last seconds, there's no relation between subsides as time in times n plus one times n two n relation. The same for value subsides of all quantities possible. This quantity should satisfy some equality. That's what's an indication. To show and should have assumptions. This is the technical lemma. This can show you. This can show you positive. So all the time, see our please check these assumptions. Assumptions. Okay. Other thing is to have explication and the values of all the then H1, H2, and HN. This is consider sentence just one. Six slides, and we can go and tell you others. Okay. So we need this assumption to so we can just return this time exact times. We are interested exactly by this term. It's not just to solve this needs close to the goal. We want to have this entity because it's interesting to find the best value. This is all ways. And then we can consider a subject from this very story. So, such a journey. And this results from the situation where we have a fixed definition. Because a fixed definition is really works for difference. And then the evidence of the solution. This can be function fixed in statistics. So if we have a fixed process of imaginary process, we can use section. This expression, which from one variable, which edge, two cancels we can't do that in this situation. Okay? This is really so we see is an adaptation in functional data. To distribution so some observation considering this suggest the strategy and quadratic density and GTM we find the star difference between these two entities. One important assumption is that the edge This information we have by the before, the maximum and we find that the true shows the knowledge. So I want to see this and to see, for example, the expectation of video workshop and the classical video in relation to all this position. And you see here that the assumption that is proposed in the literature is but the assumption that fully satisfied in order that the two will with each other. Also the chicken difference of distance of true so now we go to some simulation. As the second structure, have some outliers as indicated some outliers. Okay? And we see if possible to classify. If this was just after considering sample, just the outlier and test. You can see that first smarter is only the classical evaluation. Now I utilize supervised classification and here I use some additional tests. So here just checks. We see the literature was 2002. When we consider this is natural, shows of show us 2021, jurisdiction to the lens and the other entity. So just some one, second one, see how the size make a mistake. Of solutions. Considering solutions for solutions, transitions. And we consider mixture first, second, third, second teachers, and consider that as first class or second class, third class. See a sample of 75 sample each class. We can see that we can make mistake, for example, from class 2 and 2 for one curve. And to compare our symmetry, consider two sequence of sets is given. Now, learning something, also test something. And then 75 and from first class to second class. The same and for each class, two class and for two separate results. The same thing for testing. 25. I chose this is bigger than really something. And the one which is 2 this is, you can see that when you apply quite similar error. This is our proposal. This is the scenario. We see the average. Estimation shows that 268 seconds, while the nearest recursive one 1139. That means about 3 times less. Okay. So now we can see slowly than this, but little bit more precise calories, not so 20 minutes, not less. But if we consider much more, for example, for it's just simulation. Some and consider what complicated situation. That's where we have for each class it change the same number and coming from 2 separate data sets. And we consider the system much more bigger than the medium. We're just 100 each time, 150, that means less than 500. That's 4,000. Same. And let's see. One can see it work better. This is about 15% of error for recursive, and just 15.5 of error. The difference is not so good. But if you see the time, we obtain this result about 35 minutes, and at 1.1, we should 40 hours. And then we can see it's simple. So same use. Just to talk to a patient and to take 2 weeks of time to look and get through. Okay. Then you can go around. It's done in 2 weeks. Supervised classification. In this example, we compare to EEG data. So we are just looking to compare the small variability, which is for each situation of each story, the number of stories that satisfy this frequency. And we consider all of this actually like sets of values. Same symmetry. It looks like somebody these observations and something geological this symmetry, some assumption, there also so it's elegant to this assumptions to satisfy upwards almost complex conversions super estimator and also logical. So just I give you some view about political this estimator and classical the application. So the application as I say participant seats. So scheme and so show as quick as possible, as close as possible. And this first start of six four steps. First one is C, which is the second one. This is objects. Access to the world. Question. Following, right? And we want to associate this part to this hash. So and this is situation and 28 electrons of the world. So one question, participants. There's one. And it's special 128 electrons. And our objective is to remove the energy electron in the states of proximity. And we know that it's decompositive 52 time frame, and it appears at 40 time frame at finish at 80 time frame. Because of the beginning, we see energy actually go to other things. We will not stay still, so just in the normal person, can see the understand what it means and stop working. So, even the 1928 to 2085. Situation. So we consider stochastic sheet boundary situation and we want to compare this to so the stochastic let's mean we make C probability from two direction to a class C CTI, which means this two lots with the same other nodes if they belong to the same class. And the same for the second class, the same for the third class, if we suppose we have three classes, and the same for the first one, and the second for all the election, for the third class, and the other one, same for let's go to election participating to the first. Select. So it's working like that. We have a line which called distribution. We consider that in each edge, it's generated as a joint function. This means for electron. All the activated at the same time is activated. It's from the volume. They are inside, das means zero. Das means this flexible, it's flow like every. And for oxygen, I like the difference of accenting flows and regional distribution so I agree with this situation. It exceeds all of this. So we can consider so this situation is very important to minimize our letters. So we can consider expectation maximization algorithm, which is C first expectation depends on sensitivity. The expectation maximization algorithm is based on two steps. The first one is to calculate expectation of observation. So you suppose to have a variable. Now this variable is really shorter with parameters. Okay. And maximization to update this our estimation. But in this situation, it is not trying to do because of the dependent variable. Approximation of the unknown distribution by distribution. And we realize that a fraction of the distribution. And try to minimize this kind of solution by maximizing the volume, as we maximize this quantity. And this quantity can rises. Quantities which is as size then city and finally the temperature and then the temperature of the atoms and now it's also true the number of glass and so expectation making is the point of final and the situation can find maximum and will apply to society to become customers. And here you can see that is from society. See also to check. Exactly what time and it starts at 4:25, it's finish 4:85. Let's see what it finish. Let's see 4:85. We see if we use the classical method. any of S1, and basically just one layer in each edge, you assign just two class, and we can check for
Excuse me, Professor. There are 10 minutes.
Also for this can check 40 times 80 times 15 to 10. And we compare the two methods, we see that there are some differences. First one, second one, of 82%, which is satisfactory. And I see that's possible. No overlapping to and see that there are some to change the class time. But with this assumption, it can be considered, but what we consider just the overlapping, so we can be some question for perspective. Essentially, if we have observation, informations change by the meaning for self, the service, and others. And this is stochastic change over time. And this assumption is considered change. Just carry next time the calculation I think for our and the information which is accessible.
Okay, thank you for the engaging presentation, Prof. Yousri. Now we will move on the question and answer session. Maybe for the participant in the Senat room, you can, if you have any question for Prof. Yousri, you can raise your hand. Okay, Mr. Fikri.
Good afternoon, Prof. I have a question. When we confidence with our model, especially with high dimensional data, or P more bigger than n, because for validate we just a little samples. That is my questions.
Okay, thank you for the question, Mr. Fikri. Please, Prof. Yousri, to answer.
No. In slide, I give different see. I started by the situation in which it is better to consider fiction parallel to fixing solution. One situation also is considered because check why it is not usually question which explains between the two. But in the situation I will see as synthesize and also it's for example, some situation we take from questions. We have observation in the but it can in the other reasons. But we can learn later. We have this information for questions. So the difference grade. So this is one of situation of which values possible statistical. There are also which is combination between exceptions. Check which are
Because my research is about the functional group functional with surrogation probe, and I will try to some model lasso. I use three models, and the validation evaluation model validationnya different. So I apa ya? Sorry, I confuse which the models more better gitu. So with the little samples, I will saya I still confused with the sample.
problem in the situation we have. This is why I say that this one for very fine solution should presence should situation. Since I'm done, let's consider assumptions just trajectory.
Okay, I can see from my laptop first. Maybe. Okay, Prof. There is one question from Cindy Angelina, Universitas Tanjung Pura. Good evening, Prof. Yousri. As I was reading about the double EG experiment about image naming task, I read about this part. Double EG activity was recorded using a system of 128 electrodes distributed over the surface of the scalp during the initialization latency. And the question is, what does it mean when electrodes are more active? Does this stronger activity in certain part of brain equal to that part working harder? And is that how researchers find out which part of brain responsible in doing certain job or task? Thank you.
Okay. Let see us there for this when it more active.
Okay.
More active, that's more but it's really so so usually that was in action. No. Okay. So make an assumption of it's more severe or not. Because we make a way of between each edge, when the solution is activate or not, this two, for example, we have some sign or not, and we see the difference between the activation between one electrode and others neighbors. Okay, and this is the true information that I have. So if it's more activates, then certainly we will have less class. Yeah, that's what we will have. So this, it could be if we use stochastic block as we propose, we can obtain some results if they are not activated, and this minimized class. And what I see, it's more complicated than this. Continuous where they are overlapping, which is interesting because you can make some new application, including one EEG. I just want to participate to change different touch. And even if the activation or activation have different class. And also for unique, which because we consider that in each position, we take SW. As I see in the end, that in each position, we consider like here. And each time we make SW to classify this electron, we see that there are differences. We can find difference. That's in this time, the people small activates in this time. This is why so this is why we should consider an exponential rate, for example, and consider dynamic stochastic. That's I think for function just from this less class.
Thank you for the answer, Prof. Yousri. Thank you, Cindy Angelina from Zoom meeting. Is there any question? Okay, Cinta. Please go in front, Cinta.
I just want to ask, what's the challenges that face as you try to form the estimator or a dependable predictor from the real data? Because we all know that real data is quite complicated since it has lots of noise and all. And I just want to know what you do to face or overcome that problem that you face as you trying to make a dependable predictor. That's thank you.
So, so the construction of simulation is challenging. So, what I would like to consider simulation. Those to pure costs. Just challenging to make the assessment property. First, most among the second, and we see this interesting to make for classification and classification the application. This is why we start with supervised classification, and then for the supervised classification, it's survival. She moved to stochastic model and consider its EEG and check what you can have time to see
Okay, thank you, Bro. Is there any more question from the Senatro? Or maybe is there any more question from Zoom chat? No? Mrs. Anita or Mrs. Fitriani, is there any question? Adika Dapo? Question? Mr. Franz? Okay, if no more questions, maybe we will wrap up today's session. We have learned how stochastic approximation algorithms can be used effectively in analyzing functional data, especially in big data settings like EEG signals. Professor Yousri Sloui showed us how recursive estimation and non-parametric learning can be applied in real-world problems from environmental data to neuroscience and speech recognition. This talk highlighted how modern statistics and machine learning come together to address complex high-dimensional challenges. As we reach the conclusion of this Studium Generale, I would like to express our sincere appreciation to Professor Yousri Sloui for his insightful, inspiring, and academically enriching presentation. Your expertise has illuminated important aspects of modern statistics that bridges theory with real-world application. To all participation in Senatrom and also in Zoom, thank you. Thank you for the appreciation for this meeting. We hope this session has sparked new perspectives and potential collaboration across disciplines and borders. On behalf of the organizing team, I, Dr. Evi Sulistiningsih, look forward to welcoming you again at our future academic events. Assalamualaikum warahmatullahi wabarakatuh. Thank you.
The next agenda is the presentation of a token of appreciation to our speaker and moderator. First, we kindly invite Mr. Professor Dr. Yousri Sloui, and we request for Mrs. Dr. Nilamsari Kusumastuti willingness to present this appreciation for our honorable speaker. Okay, take the documentation in 3, 2, 1. Once again, in 3, 2, 1. Okay, thank you very much, Professor Yousri. Please give applause for Professor Yousri Sloui. Okay, next, Mrs. Effie, our moderator for today, please come forward, and we request for Mrs. Nurfitri Imro'ah willingness to present the appreciation for our moderator. Okay, the documentation in 3, 2, 1. Once again, in 3, 2, 1. Okay, thank you very much, Mrs. Effie. And once again, to all the participants, please give a round of applause for our incredible speaker and moderator. By this final session, we have reached the end of today's Studium Generale. As the master of ceremony, from my deepest heart, I would like to apologize for any mistakes I may have made while leading this event. I excuse myself. Thank you for your participation and support. Wish you a safe journey. Goodbye and see you at the next event. Wassalamualaikum warahmatullahi wabarakatuh.